Welcome to Reimagine Healthcare. I'm your host, Noah Voles. We've covered a lot of ground in this series. In episode 1, we built the biological foundation, the deodyinase system, the difference between T4 and T3, why TSH is a thermostat reading and not a room temperature, why Hashimoto's is a systemic autoimmune condition and not just a thyroid problem. In episode 2, we got specific about the labs, what should be measured, why the standard panel is insufficient, why free T3 needs to be measured by mass spectrometry and not immunoassay, what reverse T3 tells us, and what Kathleen's extended labs finally revealed after 3 years of standard testing that had missed important things. Today, we close the loop. We talk about treatment. We follow Kathleen through the 6 months after those lab results changed everything. We dig into the evidence for combination therapy versus levothyroxine alone. Honestly, without the ideology that tends to surround this debate on both sides, we look at what functional medicine gets genuinely right in thyroid care and where it goes beyond the evidence. And we end with something concrete, a direct argument for what Southern Oregon's healthcare ecosystem needs to build so that patients like Kathleen don't have to spend 3 years disappearing before someone figures out what's actually wrong. But I want to start with the cliffhanger I left you with at the end of episode 2, because it's important and it reframes the treatment conversation in a way that I think is genuinely useful. Kathleen's extended labs showed that her free T3 to reverse T3 ratio was 0.075, well below the threshold that suggests adequate deodyinase balance. Her conversion machinery was running in suppression mode. But here's the thing. She had been on Armour Thyroid, a desiccated thyroid extract that contains both T4 and T3. She was already getting T3 in her medication. So why wasn't it working? The answer to that question is the key to understanding why thyroid treatment is more nuanced than either camp in this debate wants to admit. And it starts with understanding something about how T3 behaves in the body when you swallow it as a pill. T3 has a half-life of about 12 hours, which means that when you take an oral dose of T3, it absorbs relatively quickly, peaks in your bloodstream within a few hours, and then starts to clear. By the time 12 hours have passed, half of it is gone. By 24 hours, most of it is gone. This creates peaks and troughs, a period of relatively high T3 after the dose, a period of relatively lower T3 before the next dose. Now compare that to how a healthy thyroid delivers T3. It doesn't deliver it in a single daily bolus. It secretes small amounts continuously throughout the day, producing a stable, steady supply to peripheral tissues around the clock. No peaks, no troughs, just a consistent signal. When you take Armour Thyroid or any T3 containing medication in a single daily dose, you're getting a T3 pulse rather than a T3 stream. And for some patients, particularly those whose deodyinase system is already suppressed and struggling to manage the conversion of T4, that pulse may not be providing the sustained tissue level T3 that the body needs. The T3 peak comes and goes. The tissues get a burst and then a valley. And the symptoms persist because what the body actually needs is continuity, not spikes. This is not an argument against combination therapy. The evidence for combination therapy is real, and we're going to get into it thoroughly. This is an argument for understanding that how you deliver T3 matters, not just whether you're delivering it. And it's the reason why Kathleen's treatment needed to be adjusted. Not abandoned, adjusted. So let's map the treatment landscape clearly before we talk about what happened with Kathleen. because there are three broad camps in how thyroid disease gets treated, and understanding where each one is right and where each one goes wrong is essential for making sense of what the evidence actually supports. The first camp, representing the majority of conventional endocrinologists and most clinical guidelines, holds that levothyroxine is the appropriate treatment for virtually all patients with hypothyroidism, that normalizing TSH is the appropriate treatment target, and that patients who continue to feel unwell despite normal labs should be evaluated for other causes. This position has institutional authority behind it. It reflects the care the majority of hypothyroid patients receive, and for about 80 to 85% of hypothyroid patients, it works. Levothyroxine normalizes TSH, resolves the major symptoms of hypothyroidism, and restores quality of life. I want to say that clearly because the legitimate critique of levothyroxine monotherapy for some patients should not be mistaken for an argument that it doesn't work for most. The second camp, found more often in functional and integrative medicine, holds that desiccated thyroid extract is the more physiologically complete replacement, that TSH is an inadequate treatment target, and that comprehensive testing, including free T3 and reverse T3, should guide dosing. This position has passionate patient support, legitimate scientific grounding, and a significant following in Southern Oregon's functional medicine community. It also exists in a space where overclaiming and inadequate evidence sometimes coexist with genuine insight. The third camp, smaller but scientifically rigorous, holds that the right answer is nuanced, that levothyroxine is appropriate and effective for most patients, that combination T4 and T3 therapy is warranted for the meaningful minority who fail monotherapy, and that the treatment target should be not just biochemical normalization, but symptomatic resolution. This is the position Antonio Bianco articulates in his research and his book, and it's increasingly reflected in updated professional guidelines. The evidence, examined carefully, supports the third position. So let's look at why. Let's start with levothyroxine and its limitations, because the most compelling evidence that T4 monotherapy is incomplete for a meaningful number of patients doesn't come from patient testimonials or functional medicine practitioners. It comes from mortality data. A large retrospective study published in the Journal of Clinical Endocrinology and Metabolism in 2017, comparing over 1 million patients with hypothyroidism being treated with levothyroxine against a matched population of healthy people, found that the treated hypothyroid population dies at roughly 2.5 times the rate of healthy controls. 2.5 times. Not from undertreated thyroid cancer, not from gross hypothyroidism, from cardiometabolic causes, heart disease, stroke, the consequences of lipid abnormalities, and vascular dysfunction. Now let me be careful here, because causality matters. Some of that elevated mortality almost certainly reflects the fact that people with hypothyroidism have other comorbidities, other autoimmune conditions, other health vulnerabilities that contribute to worse outcomes independent of the thyroid treatment. That's real. That's a confounder. But here's the thing that makes this hard to explain away. In the same large data set, patients taking combination therapy, T4 plus T3, had a 30% reduction in all-cause mortality compared to patients on levothyroxine alone, 30%. And the two populations were carefully matched for comorbidities, age, sex, BMI, and baseline health status. The patients taking combination therapy weren't healthier to begin with. They had the same starting profile, and they were dying at a 30% lower rate. Think about what that means. In virtually any other area of medicine, a 30% mortality reduction in a population of over 1 million people would trigger urgent calls for a prospective confirmatory trial. It would be on the front page of every major medical journal. In thyroid medicine, it has been met with cautious acknowledgement and continued institutional inertia. Why? Partly because levothyroxine has been standard of care for decades, and changing that standard requires overcoming enormous momentum. Partly because the FDA never required clinical outcome trials before approving levothyroxine. The drug was grandfathered in, approved based on TSH normalization rather than actual health outcomes. Partly, honestly, because there is limited commercial incentive to fund research that might undermine one of the most prescribed drugs in the country. And there's another piece of evidence worth understanding. In animal models, research from the laboratory of Antonio Bianco and colleagues at the University of Chicago, rats treated with enough levothyroxine to normalize TSH show persistent hypothyroidism in the liver. The liver, despite a normal TSH, continues to have impaired LDL receptor expression, impaired cholesterol clearance, elevated LDL. Does this explain something we see clinically? It does. The most commonly co-prescribed medication with levothyroxine in the United States is a statin. Patients with hypothyroidism go on levothyroxine. Their TSH normalizes. Their cholesterol often does not fully normalize, so they go on a statin, and the physician considers the thyroid treated and moves on. But the liver may still be relatively hypothyroid, still not clearing LDL effectively, still contributing to the cardiometabolic risk that the mortality data is measuring. So what does combination therapy actually look like in practice? And what does the evidence say? There are two main approaches to combining T4 and T3. Synthetic combination therapy, levothyroxine plus liothyronine, which is synthetic T3, gives precise, adjustable control over both hormones independently. You can dial the ratio up or down based on how the patient responds. You can adjust the T3 dose without changing the T4 dose. You have pharmaceutical-grade consistency in both molecules. Desiccated thyroid extract, DTE, the dried and standardized powder of pig thyroid gland, provides T4 and T3 in a fixed ratio of roughly 4:1. It's been used to treat hypothyroidism since approximately 1900. It predates the FDA, predates the isolation of synthetic levothyroxine, predates essentially everything we now know about thyroid physiology, and it has been used continuously since then by a substantial patient population. Let me give you the honest evidence on DTE, because this is where the debate gets most heated and where clarity is most needed. The safety concerns historically raised against DTE, that the T3 component produces dangerous T3 spikes, damages the heart, accelerates bone loss, have not been borne out in controlled trials. Head-to-head safety comparisons with levothyroxine show equivalent profiles. There is not a single study demonstrating that DTE causes harm that levothyroxine does not. The patient preference data is striking. In blinded crossover studies, where patients don't know which treatment they're receiving, so expectation and placebo can't explain the results. Patients prefer combination therapy over levothyroxine alone at roughly a 2:1 ratio. A 2013 double-blind crossover trial published in the Journal of Clinical Endocrinology and Metabolism, the CAT study, led by Dr. Antonio Bianco, found that 48% of patients preferred DTE compared to 18% who preferred levothyroxine. That's not a small signal. That's people who have no idea what they're taking telling us in significant numbers that one option makes them feel better. The potency of DTE has been standardized by the United States Pharmacopeia to within plus or minus 10%. Manufacturing quality is regulated by the FDA. It's a controlled medication that happens to have been around longer than the regulatory framework that governs it. The legitimate concerns about DTE are practical, not ideological. The T3 component has a 12-hour half-life, as we discussed, and produces a post-dose peak that some patients find uncomfortable. The ratio of T4 to T3 is fixed. You can't adjust it independently the way you can with synthetic combination therapy. And manufacturing quality does vary between brands. There have been recalls for DTE and for levothyroxine both. And patients taking DTE should check the FDA website periodically for current recall status. There are approximately 1.5 million patients in the United States currently taking DTE. Another 400,000 taking synthetic combination therapy. These are patients who, in significant numbers, found their way to combination therapy because levothyroxine alone was not enough. There is a version of the DTE conversation that I think does real harm to patients, and it comes from the most enthusiastic end of the DTE advocacy community. The framing that DTE is the only natural, correct, truly human approach to thyroid replacement. That levothyroxine is a pharmaceutical industry conspiracy against patient health. That any physician who prescribes T4 monotherapy is failing their patients. This framing is not supported by the evidence. Levothyroxine works well for most patients. Ideology dressed up as medicine helps nobody. The evidence supports offering combination therapy to patients who fail monotherapy. It does not support abandoning T4 therapy for everyone, and physicians and patients who understand this distinction are in a much better position to have productive conversations about treatment than those who've decided the answer before looking at the evidence. Now I want to talk about something that is coming in the future of thyroid treatment. Because the central pharmacological problem with oral T3, the peak and trough, the 12-hour half-life, is one that researchers are actively working to solve. And the solutions are closer than most people know. The holy grail of thyroid pharmacology is a slow-release T3, something that mimics the thyroid's natural continuous secretion rather than delivering T3 in a single daily pulse. Two approaches are in development right now. The first is being developed in the United States. It uses a polymer matrix in which T3 is embedded and released gradually as the polymer breaks down in the intestine. Phase 1. Clinical trials have been completed successfully. The developer is working with the FDA through an accelerated regulatory pathway that should shorten the approval timeline significantly. The second approach is being investigated in Europe. It uses T3 sulfate, an inactive form of T3 that is absorbed orally and then converted to active T3 by a liver enzyme called sulfatase. And here's the elegant part. Sulfatase converts T3 sulfate to T3 at a steady rate-limited velocity, which means the liver becomes a continuous, self-regulating source of T3 to the circulation. As long as you're taking T3 sulfate, your liver is releasing active T3 at a constant rate. No pulse, no peak, no trough, just a steady stream. Exactly what a functioning thyroid provides. Neither of these is available to patients today, but when they become available, they will likely transform the treatment calculus entirely. The peak and trough concern, the most legitimate objection to T3 containing therapy, goes away. The argument for levothyroxine monotherapy as the only safe option becomes much harder to sustain. Now I want to address a practice that exists in Southern Oregon and in functional medicine communities across the country that I think deserves honest scrutiny. Compounded controlled release T3. Compounding pharmacies offer preparations of T3 that they describe as slow release or controlled release. The appeal is obvious. If the problem with oral T3 is the pharmacokinetic peak, then a slow release version should solve it. And for patients who feel they can tolerate 15 micrograms of a compounded product, but not 5 micrograms of pharmaceutical grade liothyronine, the idea that the compounded version is releasing more gradually feels intuitively compelling. Here's the problem. There is not a single published study demonstrating that any compounded controlled release T3 preparation actually produces a slow release pharmacokinetic profile. One study published in the Journal of Clinical Endocrinology and Metabolism in 2013 specifically tested products claiming slow release characteristics and found them to be pharmacokinetically identical to standard immediate release T3. The pharmacokinetic claim has not been validated. And there's a practical quality control problem on top of that. T3 is measured in micrograms. 5 micrograms is a vanishingly small amount. Accurately measuring and distributing that amount of active compound in a tablet or capsule is technically challenging even for the most sophisticated pharmaceutical manufacturers. Compounding pharmacies, even reputable, well-regulated ones, are working with methods that were not designed for microgram level precision. The consistency of compounded T3 preparations from batch to batch, and even within a batch, cannot be assumed. I'm not saying that patients who feel better on compounded T3 are imagining things. They may genuinely feel better. The improvement may be real, but the mechanism attributed to it, controlled release, is not supported by the evidence. Until a compounded product demonstrates slow release pharmacokinetics in published peer-reviewed research, patients and physicians should be cautious, even from high-quality compounding pharmacies. Now let's talk about the functional medicine interventions that are genuinely well supported, because there is real value in what the functional medicine community has been doing for thyroid patients. Value that conventional medicine has been slow to recognize. And it's important to separate what the evidence supports from what it doesn't. Selenium supplementation in Hashimoto's. This is the most evidence-backed intervention outside of hormone replacement itself. Selenium is a structural component of the enzyme machinery that converts T4 to T3. Multiple randomized controlled trials have shown that selenium supplementation, typically 200 micrograms daily of selenomethionine, reduces anti-TPO antibody titers in Hashimoto's patients and may slow the progression of thyroid destruction. The mechanism is understood. The evidence is replicated. This should be a standard recommendation for patients with Hashimoto's, not a functional medicine add-on. Vitamin D optimization. Low vitamin D is associated with higher anti-TPO titers and more aggressive autoimmune thyroid disease. Supplementing to achieve levels between 50 and 80 nanograms per milliliter is low cost, low risk, and supported by mechanistic and observational evidence. This is worth checking and correcting. Iron and ferritin repletion. Not controversial at all. Treating iron deficiency in hypothyroid patients is just good medicine. The overlap between iron deficiency symptoms and hypothyroid symptoms is clinically important. And a ferritin that sits inside the normal reference range but below 50 to 70 nanograms per milliliter may be impeding thyroid function in ways that look like undertreated hypothyroidism. Anti-inflammatory diet and lifestyle. The inflammatory burden of autoimmune disease is influenced by diet, sleep, stress, and physical activity. Anti-inflammatory dietary patterns, whole foods, adequate protein, omega-3 fatty acids, minimal ultra-processed food, are supported by substantial evidence in the context of autoimmune disease broadly. For Hashimoto's specifically, no single dietary intervention has been proven in large randomized trials. But the mechanistic logic is sound and the direction of the evidence is consistent. Gluten elimination in patients with confirmed celiac disease or documented non-celiac gluten sensitivity. The co-occurrence of celiac disease and autoimmune thyroid disease is well documented. They share immune mechanisms and they co-occur at rates significantly higher than chance. Treating celiac with a gluten-free diet can reduce anti-TPO titers, stress reduction, and sleep optimization. I know this sounds like soft advice. It isn't. Chronic psychological stress and sleep deprivation elevate cortisol and inflammatory cytokines, which suppress D1 activity, which shifts T4 conversion toward reverse T3, which is exactly the mechanism behind that elevated reverse T3 Kathleen's lab showed. Managing stress and sleep isn't just wellness advice. It's directly relevant to thyroid hormone metabolism. It's mechanistically grounded. Now, where does functional medicine in the thyroid space go beyond the evidence? High-dose iodine supplementation. There is a significant strand of functional medicine thyroid practice that recommends iodine doses of 12.5 to 50 milligrams daily. That's milligrams, not micrograms. The recommended dietary intake is 150 micrograms, that's micrograms, for adults. These practitioners are recommending doses that are hundreds of times the dietary guideline. The theoretical justification involves saturating thyroid iodine uptake to prevent cancer and support hormone production. The actual evidence does not support this practice. Japan, where dietary iodine intake averages 500 to 600 micrograms daily, well above Western levels but far below supplement dose recommendations, has a measurably higher incidence of autoimmune thyroid disease than iodine-sufficient populations. High iodine intake increases the antigenicity of the thyroid. It can trigger or worsen Hashimoto's. It can precipitate iodine-induced hyperthyroidism in patients with nodular thyroid disease. The risk is real, and the benefit is not demonstrated. This practice should be avoided. Now let's get back to Kathleen, because her story is where all of this becomes real. After her extended labs came back, her physician made a decision that was, in its way, remarkable for being practical and honest. She said, "We need to address the depletions first, before we change the thyroid medication. Before we try to optimize the conversion ratio, we need to make sure the machinery has the raw materials it needs to function." So Kathleen started iron supplementation. She started vitamin D3 with K2, selenium at 200 micrograms daily, recheck planned at 90 days. And then her physician did something that had never happened in 3 years of Kathleen's thyroid care. She made a phone call to the functional medicine practitioner Kathleen had been seeing in parallel, in a separate world, with no communication between the two providers. They compared notes. The functional medicine provider had already been working with Kathleen on an anti-inflammatory dietary approach and supporting better sleep hygiene and stress management. They agreed on a shared set of biomarkers to track. They agreed on a timeline for reassessment. They divided clinical responsibility in a way that made sense. The PCP would manage the medication and monitor cardiovascular risk. The functional medicine provider would continue supporting the lifestyle interventions and nutritional optimization. The decision was made to change her thyroid medication, not because Armour thyroid is bad, but because for Kathleen, the fixed ratio and the single daily dosing weren't providing the sustained tissue level T3 she needed. She transitioned to synthetic combination therapy, levothyroxine plus low dose liothyronine at a ratio of approximately 4:1. The T3 component was split into 2 daily doses, morning and early afternoon, to smooth out the pharmacokinetic curve and reduce the peak and trough dynamic. At the 6-month mark, the numbers told a different story, and Kathleen was teaching a business planning workshop. Her words came easily. The fog had lifted. She wasn't pain-free, but the chronic ache in her joints had quieted from a shout to a murmur. She had stopped canceling things. That is not a miracle story. It's a realistic story. 6 months of carefully sequenced, evidence-based intervention addressing multiple problems simultaneously. Not a single magic solution. Not a reversal of everything that had gone wrong, but a meaningful, measurable improvement in a woman who had been told, implicitly and sometimes explicitly, that her labs were normal and she should probably look elsewhere for answers. She deserved that outcome 3 years earlier. Which brings me to the part of this episode I care most about. What Southern Oregon needs to build so that Kathleen's story becomes the norm rather than the exception. Because here's the hard truth. What produced Kathleen's good outcome was not a system. It was a series of accidents in her favor. She happened to find the right book. She happened to have a primary care physician willing to listen. That physician happened to make a phone call to a functional medicine provider that she had no structural reason to make. The two providers happened to be able to work collaboratively rather than defensively. None of that is guaranteed. None of that is built into the care infrastructure. And for every Kathleen who gets those accidents, there are dozens who don't. So, what does the infrastructure need to look like? First, a shared diagnostic protocol. The most immediately actionable change would be the adoption of a standardized comprehensive thyroid panel by primary care practices across the Medford Grants Pass corridor. A protocol that includes free T3 by LCMS/MS, reverse T3, anti-TPO, and anti-thyroglobulin antibodies, and nutritional cofactors as the baseline workup for any patient with hypothyroidism or persistent hypothyroid symptoms. This doesn't require new equipment. It doesn't require new specialists. It requires agreement. A shared standard championed by regional medical leadership that establishes a higher floor of diagnostic comprehensiveness. Second, care coordination pathways between conventional and functional medicine. This includes community health centers like La Clinica and Rogue Community Health, which serve many thyroid patients in our region. The parallel silo problem is solvable with relatively modest investment. Shared care plan templates, a regional secure messaging system that crosses practice boundaries, agreed upon referral protocols that include specific information exchange requirements. Any of these would begin to build the connective tissue the region currently lacks. Third, insurance advocacy for comprehensive testing. Free T3 by LC-MS/MS and reverse T3 are not exotic tests. They are available. But insurance coverage is inconsistent and prior authorization takes time that physicians in busy practices don't have. Patient advocacy organizations, regional medical societies, and healthcare system leadership can collectively push for coverage standardization. The argument is straightforward. The cost of comprehensive testing is a fraction of the cost of years of inadequately treated hypothyroidism. The cardiometabolic complications, the psychiatric comorbidities, the lost productivity, the downstream healthcare utilization. Fourth, continuing medical education. The PCPs of Southern Oregon were trained in a framework that the research of the last 2 decades has substantially updated. That is not their fault. Medical knowledge evolves faster than medical education, but the gap between what the science supports and what patients receive is real, and it's closing slowly. Regional CME programs, grand rounds presentations at Asante and Providence, educational collaborations between conventional and functional practitioners, these can close the gap faster. The goal is not to turn every PCP into a thyroid subspecialist. It's to raise the floor of thyroid literacy high enough that patients don't fall through it. Fifth, a prospective outcomes registry. One of the most valuable things Southern Oregon could contribute to the national thyroid conversation is real-world longitudinal data, a voluntary registry of hypothyroid patients tracking biomarkers, treatment approaches, symptom outcomes, and quality of life over time would generate the kind of evidence that academic clinical trials are too slow and too expensive to produce. What are the real-world outcomes of comprehensive versus standard testing? What is the actual response rate to combination therapy versus monotherapy in a community-based population? What is the relationship between anti-TPO trajectory and long-term cardiometabolic outcomes? I want to close today with something I've been thinking about throughout this series, because at its heart, this story is about information asymmetry and about what happens when that asymmetry gets corrected. Kathleen's physicians had information she didn't, about the limitations of the standard approach, about the existence of tests that could tell a more complete story, about the evidence for treatments beyond levothyroxine monotherapy. She had information they didn't, about what it felt like to live in her body, about the gap between what the numbers said and what her life looked like, about 3 years of diminishment that the labs declared acceptable. Good medicine happens when both kinds of information are in the room at the same time, when the patient's lived experience is treated as data, when the physician's training is a starting point for inquiry rather than a closed file, when the biochemistry and the biography inform each other. If you're a patient in Southern Oregon who has been told your labs are normal while you continue to feel unwell, you now have a vocabulary. You know what to ask for. You know which tests matter and why. You know that your experience is not in your head, and you know that the science supports taking it seriously. That's the work, and it's worth doing. This podcast is investigative health journalism. It is not medical advice. I'm a clinician acting as a journalist and healthcare advocate. The goal of this series has been to help you ask better questions of your physicians, not to replace their clinical judgment or tell you what to do with your own health. Every person's thyroid situation is individual. The research we've drawn on is real and peer-reviewed, but medicine is complex, and decisions about your health should always be made with a qualified provider who knows your full picture. If I've gotten something wrong in this series, I want to know. Leave a comment. You can reach us at reimagine-healthcare.org. And thank you for listening.